My name is Dom Goetz, and I live in St Just, and I have a degree in environmental science from Plymouth University that I completed 21 years ago. In the last 20 years or so, I've spent most of my time working in the environmental movement, from consultancy in sustainable agriculture, ecologist in Vietnam and Tanzania, sustainable construction and sustainable construction consultancy. And now, on the 22nd of January this year, Cornwall Council declared a climate emergency. And the purpose of tonight's talk is to examine what that means and what we, both as individuals and as a community, should maybe do about it. Honestly, I do not want to be standing here giving this talk tonight. I'm completely out of my comfort zone, but I feel that I have a duty to speak the truth, to the best of my ability, about a subject that I've been following for a long time. So tonight, we're going to look at what scientists are telling us is happening now, to the natural world and to the climate. And what does that mean for us? So last year in October, there were two very important documents published. The first was the IPCC's special report on global warming of 1.5 degrees C. And the second was the Living Planet report, published by Worldwide Fund for Nature. They're alarming, to say the least. But I hope that they might spur us on to take action before it's too late. So let's start by looking at how we humans look after the planet that we depend on for our survival. One way of looking at human impact is ecological footprinting. It looks at all the impacts such as farming, consumerism, mining, pollution, etc., and it compares them with the ability of the planet to regenerate over a year. So one way of looking at it is World Overshoot Day. So this is the point each year at which humanity exceeds the capacity of the planet to provide energy from sunlight, fish from the seas, timber from the forests, and mop up our pollution. So the idea is that you should be able to get at least to the end of the year before you've used up your natural capital, the income of the planet. In 1987, the planet as a whole, we got to the 19th of December before we started to run a deficit. And as time has gone forward, that date has moved further and further back through the calendar. In 1995, it was November the 21st. By 2005, October the 20th. In 2010, August 21st. Another way of looking at that is by country, on a country by country level. Sorry, go back. Currently, to meet our needs, we would require 1.7 planets to meet all our needs. But the share of blame is not equal. You can look at it from a national perspective. Vietnam, for example, gets all the way to the 21st of December before it's in the red. In the UK, we get to the 8th of May, and in Qatar, only the 9th of February. So the UK, if everybody on the planet lived to the same standard as we do, we'd need 3 planets. And if everybody lived to the same standards as they do in Qatar, we'd need 10 planet Earths just to get by. It's insane. In fact, we use so much of the Earth's carrying capacity for ourselves and our diet that there's little space left for other species. We are in the middle, or in the midst of, the 6th mass extinction. The rate at which species went extinct in pre-human times is called the background rate. Estimates for current extinction rates are between 1,000 to 10,000 times greater than that. In the UK, the original puffin population was reduced by 1/3 in 2008, and a further 12% in only the past 12 years. The reduction of other species passes by almost unnoticed. If you're my age or older, you'll probably remember what it was like driving around in the summer. The windscreen would be splattered in flies, wasps, and bees. It doesn't really happen anymore. In Germany, they've lost, in the last 25 years, 75% of all their flying insects. These are essential for all food chains. They're essential for pollination and sustainability of vegetation. And when they're gone, we're toast. A 100 years ago, about 80% of the world's mammals were wild. Now only 4% are wild. 36% of mammals are humans, and a staggering 60% are livestock. We teach our children about a world full of great animals, like lions, tigers, elephants, giraffes. But in reality, the world is full of cows, pigs, sheep, and humans. In my lifetime, I'm 48, the number of vertebrates, that's mammals, reptiles, fish, and amphibians, has declined by 60%. And if I live to be 80, it'll have declined by 90%. Our insatiable appetite for consumerism is powered by fossil fuels. And it's these that are the predominant source of climate change, as well as gases used in refrigeration and the methane that comes from livestock. Perhaps if we could visualise the effects of burning petrol, diesel and oil and coal, we'd be less complacent about it. But we don't really see it, so let's try and get a sense of perspective. So, first of all, to get an idea of the size of our atmosphere, if you go outside and you look up into the sky on a clear day, you look up and it looks like the sky goes on forever, and you think, well, you can probably chuck quite a lot of stuff into there and it will just get dissipated and it'll be all right. However, if you put it into scale, that the Earth is this ball, then in fact, the thickness of the atmosphere is the equivalent of the thickness of a piece of cling film. And if you take that off, it's now not going to come off. And you scrunch it up, you see that it's really not very big at all. Now let's get an idea of the timescale in which we're operating. So the Earth is 4.5 billion years old. And if I use a 5 metre tape measure, and we go 4.5 metres out, Sam, can I just get you to hold that? So on this tape measure, 1 millimetre represents 1 million years. We've got to go to 2 metres out roughly before we get any oxygen in the atmosphere. And we've got to go to 4.1 billion years before we get any serious vascular plants, so that's grasses and trees. And At what point does anyone think that humans might appear on this?
Way over there.
Way over there, exactly. Let's just find out if I'm leaving anything. So one thing about vascular plants, which have appeared 400 million years ago, is that as they decompose and fossilise, some of them become fossil fuels. So, Homo sapiens, we've got 4.5 billion years in total, so that comes to here. At what point do we get humans, do you think? It's the last fifth of a millimetre. So we're pretty new on the scene. So let's get thank you very much. So if we then zoom in to all of human history, the last 200,000 years, into 2 metres, and get an idea of what we've been up to in that time, well, for most of that time, in fact, all the way up to 12,000 years ago, we've just been hunter-gatherers. There's been a few million of us, maybe 100, 150 million people scattered around the planet, and they've been hunter-gatherers, and that's been pretty steady. About 12,000 years ago, some bright spark realises that you can domesticate plants and start agriculture, and human numbers increase. About 5,000 years ago, so that's 2 inches from the end here, so here, we get kingdoms, money and writing. And then about 500 years ago, so 5 millimetres from the end, we get science and capitalism. And then right at the end, in the last 2.5 millimetres, so that's 2.5 centuries, we get the Industrial Revolution. Things change pretty dramatically during the Industrial Revolution. Since 1750, humans have released 1.5 trillion tonnes of carbon dioxide into the atmosphere. Well, that's just a very big number, and it doesn't really mean anything, does it? So, to help us visualise that, let's think about how much carbon dioxide is emitted from a forest fire. A forest fire of an acre produces about 4 tonnes of carbon dioxide. So, now imagine a distance 1,500 miles. That's the distance between London and Athens. So say you get in your car and you take the ferry and you drive to Athens and you drive at 60 miles an hour for 25 hours non-stop and you arrive in Athens. Now imagine that that is one side of a square. And you look out, and there's a square 1,500 miles by 1,500 miles. And it's covered in forest. And that forest is on fire. And that forest burns every year to the ground for 270 years. That's how much carbon dioxide we've emitted since the Industrial Revolution. But it's worse than that, because in the last 25 years, we've emitted more carbon dioxide than in all the 245 or whatever it is years that preceded that. We now burn or emit 40 billion tonnes of carbon dioxide into the atmosphere every year. And that is the equivalent of burning a forest 1.3 times the size of Africa to the ground every year. I think that if any of us switched on the news and every day we saw that there was a forest fire raging like that, we'd be pretty worried about it and we'd be doing something about it. And finally, as with ecological footprinting, it's important to say that the share of the blame is not the same. The richest 10% of the planet, which we are part of, are responsible for 50% of all of the emissions, whilst the poorest 50% of the planet are only responsible for 10%. So the richest 10% are emitting 25 times more than the poorest 10%. So when we talk about global warming and carbon emissions, the thing that comes up again and again are the reports of the Intergovernmental Panel on Climate Change, the IPCC. It's been called, it's been called the most exhaustive scientific investigation in world history. And the headline of its latest report was, "We have 12 years to halt climate catastrophe," in which habitats such as coral reefs are lost, sea levels rise and lands are flooded, food production is reduced, and many people are forced to migrate from their homelands. Now, the majority of the world's governments have signed up to averting these effects by limiting global temperature rise to below 2 degrees C and aiming for 1.5 degrees C, which all sounds rather benign and reassuring. But Professor Kevin Anderson, who was the director of the Tyndall Centre in Manchester, the UK's leading academic climate change research organisation, says, "We have a 1% chance of keeping below 1.5 degrees and only a 5% chance of keeping below 2 degrees. A report called What Lies Beneath, which is written by leading scientists, including the Joachim Schellnhuber, who is the lead scientific advisor to both the German government and to the Vatican, criticises the IPCC report for being cautious and conservative. It's out of date. Its projections rely heavily on negative emissions technology, such as carbon capture and storage, which have never been proven to work on the required scale and would be unbelievably expensive. To give you an idea, carbon capture would have to be the size, carbon capture industries would have to be the size of all the industry on the planet at the moment. And at the moment, it doesn't exist. What's released for publication by the IPCC to the press and to policymakers, and this is really important, the press and policymakers are getting information that is decided on by lawyers and diplomats, not scientists. Buried deep within the IPCC report are 3 climate change scenarios. They're not released to the press or to policymakers, and in fact, written on each page of these scenarios are the words, "Do not cite, quote, or distribute." So this report, What Lies Beneath, goes on to say, and this is really important, the IPCC talks of limiting global warming to 1.5 to 2 degrees Celsius. But in reality, it sets the world on a path to 3 to 5 degrees of warming above pre-industrial levels. The risks are existential, but it is alarmist to say so. A fast, emergency-scale transition to a post-fossil fuel world is absolutely necessary to address climate change. But this is excluded for consideration by policymakers because it is considered to be too disruptive. And so we have a policy failure of epic proportion. So next we're going to look at what the scientific community is actually saying when not gagged by diplomats and lawyers. Right, I don't really like showing graphs because they're generally not terribly clear, but I think this one is relatively straightforward. So this graph describes the decline in Arctic sea ice. We have, along the bottom, we have the year 1920 to 2080, and along this axis we have sea ice extent in millions of square kilometres. These colourful lines are IPCC predictions, their best case scenario, worst case scenario. Now remember that these scenarios are relying on technologies such as carbon capture to be implemented in the next century to suck carbon dioxide out of the atmosphere. This technology does not exist. So in the best case scenario, the Arctic never goes ice-free, and in the worst case scenario, it goes ice-free towards 2080, 2090. The black line, meanwhile, is what is actually happening. These are measurements being taken now. And what we see is that this line is falling off a cliff.
Yeah.
The Arctic is predicted to be ice-free in the summer in 2 to 5 years. Now, the reason that the rate of melting is far faster than predicted is because the IPCC's models fail to include 2 extremely important phenomena. 1, locked-in warming, and 2, feedback loops. For your information, both of these things were included in first-year environmental science lectures in 1995. So we're going to look first at locked-in warming. Locked-in temperature rises are temperature rises that have been caused or will be caused by things that have already happened. When we burn fossil fuels, particularly the dirtier forms of coal and diesel, we emit aerosol particles into the atmosphere. And these particles act like a shield. They shade us from some of the sun. So carbon dioxide is making it warmer, but we're not seeing the effect because of the shading. So ironically, when we cut our emissions, we will face a one-off but sharp jump in global temperatures. An article in the science journal Nature last year published that estimates that aerosol particles may be cooling the planet by as much as 0.7 of a degree. And in an effort to clean up air quality, such as smog in China and India, many nations are actually reducing aerosol emissions much faster than predicted by the IPCC. And meanwhile, natural systems are becoming unstable and setting off positive feedback loops, or vicious circles.
Yeah.
It's perhaps easiest to demonstrate with an example. So the most well-known one is called the albedo effect. Albedo is simply a word for reflectivity. Ice and snow at the poles reflects sunlight back into space like a mirror. But as the temperature warms, the ice melts. As the ice melts, it reveals a dark sea beneath it. And the dark sea absorbs solar radiation and absorbs heat. And thus the planet gets warmer. And as it warms, so that ice melts further, and more heat is absorbed. So the warming gets faster and faster. The albedo effect is one of about 70 feedback loops. Some of these are shown here, and along with temperatures at which they might start to kick in. So we've got the jet stream, we've got the Arctic summit of sea ice and alpine glaciers also reflecting heat. We've got permafrost, which is frozen ground full of frozen methane. We've got coral reefs dying off, and we've got forest fires in both Amazon, potential forest fires in boreal and tropical forest, and we've got ocean circulation currents. The paper, Trajectories of the Earth System in the Anthropocene, which was also published last year and is also known by the title Hothouse Earth, looks at the effect of many of these feedback loops and how they might interact to push the planet into a completely different geological era. The authors say there is a point of no return. When a certain planetary boundary is crossed, possibly as low as 2 degrees C, the feedback loops trigger abrupt changes, which then kickstart other feedback loops. It's a chain reaction, a tipping cascade. Now, if you've been watching the news, in fact, if you've been reading newspapers that cover it, you'll realise that the freezing weather in North America is a sign of the jet stream collapsing. There are forest fires all around the world, from the Arctic to Australia. And there's flooding in Australia. In the last month, we had the hottest temperatures ever in Australia, followed by the greatest floods they've ever had, with wildlife being just absolutely annihilated. So these are signs that these processes have already begun at temperatures lower than anticipated. We are at an extremely dangerous point. We are currently 1.1 degrees above pre-industrial levels. We have as much as 0.7 of a degree of locked-in warming, and we're just about to enter a natural warm period called the interdecadal Pacific Oscillation that could last 20 years. So the authors of this report that was published in, sorry, is this the right one? So this was published in Nature. Sorry, let me just get back on track. So a letter in the journal Nature says, carbon dioxide emissions are still rising. Aerosol emissions are falling far faster than they thought, and we're about to enter a natural warm phase. So they estimate that we will surpass a long-term average of 1.5 above pre-industrial by 2030 and reach 2 degrees, which is possibly the point of no return, by 2045. So this line here, so this is time along the bottom here. So we have 2000 to 2050, and here we have global warming since 1850. The black line is from the IPCC's projections. It's going along here, and the observations are here, and the projections, which include all the science which I've just described, are going up here. So therefore, we're 10 years ahead of the IPCC's predictions. So they say that we are heading for warming of 3 to 5 degrees by the end of this century. At 4 degrees, 3/4 of the world's population would live in an area of deadly heat. You go outside for any long period of time, you die. What on earth would 5 degrees look like? Well, Peter Ward, who's an astrobiologist for NASA, tells us that the Earth has undergone 5 major extinction events in its past. The Cretaceous Extinction, which wiped out the dinosaurs 66 million years ago, was caused by a meteorite strike. But the other 4 extinctions were caused by build-up of greenhouse gases, mostly carbon dioxide, released by volcanic eruptions. These gases caused the polar ice caps to melt. And as the temperature between the poles and the equator, the difference in temperature decreased, so the wind and the ocean currents slowed down. The ocean stagnated and released hydrogen sulfide into the atmosphere, making it impossible for animals to breathe. During the largest of these events, the Permian-Triassic Extinction, which was about 250 million years ago, it's estimated that 96% of all life was wiped out over a period of tens of thousands of years. But we're now pumping carbon dioxide into the atmosphere at a rate far faster than has ever happened before. I've told you already that 90% of vertebrates are predicted to be wiped out in my lifetime. But it seems that at some point, humans too will disappear. And a study published last year in the Proceedings of the National Academy of Sciences said that they estimated that there was a 1 in 20 chance of human extinction before the end of this century. Unfortunately, it doesn't get any chirpier than this. And this is what I said, you know, I don't want to be standing here. It's not exactly a very nice thing to have to say on the community that you live in. The thing is, we probably won't get to that stage, or we won't experience that stage. Because way before the planet becomes that hot, it's something equally terrifying will occur. Human systems will collapse. World population has risen exponentially since the Industrial Revolution. So you can see this graphic is of population growth over the last 2,000 years. So as I said before, population stayed very, very low for most of human history. And it was only with the advent of the Industrial Revolution and medicine and science that population started to grow very fast. So in 1800, the population was at about 1 billion, and now it's at about 7.5 billion. And you probably can't read what the graphic is here. So we have a train going up a very steep incline. And the train is labelled World Food Delivery Systems. And the driver is going, I think I can, I think I can, I hope I can, I really hope I can, man, I hope I can. Well, it doesn't look very hopeful. So, as world population has increased, our food systems are struggling to meet demand. In Syria, for example, between 2006 and 2011, large parts of the country experienced the worst long-term droughts and crop failures since civilization began millennia ago. This put 2 to 3 million people into poverty, and many fled to the cities where they protested against the government, amplifying the political situation which led to the ongoing war and the refugee crisis. This year, closer to home, Dr. Jem Bendel, who is professor of the University of Cumbria's Institute for Leadership and Sustainability, made the following prediction. Last year, the disturbance of the jet stream and the Arctic vortex caused very hot temperatures in the Northern Hemisphere. This then led to a 25 to 35% reduction in grain and vegetable production. It was estimated that there were only 4 months' worth of global grain reserves. And so we only need to see a couple more summers like the last one to see a major food crisis in the Western world. Unless something massive is done now, how do we feed billions of people despite the collapse of global rain-fed agriculture? We will have a terrible situation on our hands. Which takes us back to what David Attenborough said. If we don't take action, the collapse of our civilizations and the extinction of much of the natural world is on the horizon. But the problem with words such as these is that we don't actually feel what they mean, and so we don't act. I'm going to spell it out to you what it means for a population to run out of food. This is an extract from historian Timothy Snyder's book, Bloodlands, Europe Between Hitler and Stalin. It describes a famine which was man-made by Stalin's army in 1933 in Ukraine. In Ukraine's cities, hundreds of thousands of people waited each day for a simple loaf of bread. People appeared at 2 o'clock in the morning to queue in front of shops that did not open until 7. On an average day, 40,000 people would wait for bread. Those in line were so desperate to keep their places that they would cling to the belts of those immediately in front of them. Some were so weak from hunger that they could not stand without the ballast of strangers. The waiting lasted all day, and sometimes for 2. Pregnant women and maimed war veterans had lost their right to buy out of turn and had to wait in line with the rest if they wanted to eat. Somewhere in line, a woman would wail, and the moaning would echo up and down the line, so that the whole group of thousands sounded like a single animal with an elemental fear. Survival was a moral act as well as a physical struggle. A woman doctor wrote to a friend in June 1933 that she had not yet become a cannibal, but was not sure that I shall not be one by the time my letter reaches you. The good people died first. Those who refused to steal or to prostitute themselves died. Those who gave food to others died. Those who refused to eat corpses died. Those who refused to kill their fellow man died. Parents who resisted cannibalism died before their children did. This is what can happen when we run out of natural resources. When we talk about climate disaster and the ecological crisis, this is the kind of story that we're talking about. Now, before I hand back to Manda, who's going to talk about how one might react to this kind of news, I'm going to finish this section on ecology, climate science and predictions with a quote from Dr. Kate Marvel, who's a climate scientist at NASA. She says, "To be a climate scientist is to be an active participant in a slow-motion horror story. I'm often asked to talk about hope, particularly in the current political climate. Audiences want to be told that everything will be all right in the end. Climate change is bleak, the organisers always say. Tell us a happy story. Give us hope. But the problem is, I don't have any. What we need," she says, "is courage. Courage, the resolve to do well without the assurance of a happy ending. And for that, we all need to pull together."